Hello YouTube. Today we're going to be looking at writing the explicit functions for operator equations as a function of time rather than leaving an operator form. So here we have an operator equation for a circuit that we don't know what it looks like, but we do know that this equation looks similar to what is a low-pass operator. And a low-pass operator is pretty much an algebraic equation that takes place of a differential equation. So we know the low-pass operator actually has this integral form. So the low-pass operator would simply be b times e to the negative at multiplied by the integral from negative infinity to t, e to the a alpha times the step function mu of alpha d alpha. And alpha is a dummy variable for this relationship here. Could be anything. So the real important part to note is that step function in the integrand there. So the step function can only be evaluated from 0 to t anyway, so there's really no point in putting the bounds of integration to be negative infinity to t. But when you change the limits of integration to 0 to t, that means you simplify your mathematics by pulling out the u t and just leaving the the e to the a alpha d alpha and pulling out that step function, but now it's in terms of t, so you just helped yourself a lot there. So next, all you got to do is evaluate the integral. So what is the integral of e to the a alpha? Well, that's 1 over a times itself, right? But it's evaluated from 0 to t, so e to the a alpha would just be e to the a t. But remember the fundamental theorem of calculus, f of b minus f of a. So we did f of b, now minus f of a is 0. So minus 1, because e to the 0 is 1, times the step function which we have there. And all we got to do is rewrite our equation and simplify, and boom, we have our function, we represented v1 explicitly as a function of time without even using operators, which are p. P is an operator. So it's kind of like ddt. But there you go, we did it. We represented this circuit as a function of time without using operators. And this is kind of the biggest thing here when going around differential equations and using this algebraic form, the operator algebraic forms, to find your equation that represents the circuit as a function of time. So that helps you out a lot. So I hope this video helped, and my friend actually made the video on V2, so if you want to check that out, you can see that video as well. So good luck and happy studying.